not quite sure if we have the accurate representation of the actual computer. So this is our collection phase in this process. Then we actually go through examining it. So in this case, our scenario is we have some kind of forged documents. So our hypothesis is basically that the person is using their computer to create various forged documents. So how do we test this? It's kind of the whole scientific method here. It's our hypothesis. How do we test this? We look for evidence that kind of supports this hypothesis. So we may find files that are documents or graphic images. We may have JPEGs or Photoshop files that look like the documents themselves. We could have Word or some other word processing document files that contain the forged documents. Programs that actually make these files. Evidence of printing. We found that printer there. We want to know whether they actually printed these documents and actually were the source of making them. So we want to find there's a history of printing from the system. So once we'll search for all these things using various techniques, and then we'll actually go through and analyze them to find the bigger context, to interpret them in their situation. So one example could be to compare the documents with what we found. We have some we know they were forged with. Are these the same documents that we have evidence that they existed? And then the reporting, which is the documentation, the usual reporting of what we found in the case. So as an example, this is actually one of my tools, but I tried to find other tools, but I couldn't find the screenshots on their website, actually. So this is basically an example of what we have here. In this examination phase, in this collection phase back here, the result of this was if we had a 20 gig hard drive here that we were imaging, this file is going to be 20 gigs. So this file is going to be the same exact size as the actual hard disk was. And what we do in this phase is we actually import this huge file, this 20 or 60 or 100 gig file, into some analysis software that will actually allow us to view the files and the actual data on there. So this is an example of one of the tools. This is, again, mine. It's called Autopsy. And you basically import the file in there, and it gives you the usual file manager look of listing the files, showing you the strings or the output down here, and you can get the hashes. You can do keyword searches, timeline searches, all these other various techniques for searching evidence. So that's the nice DOJ model that we have. So we'll go through a couple more that are, there's dozens of these models actually. But I'm going to give three that are kind of in separate areas in the spectrum, just to kind of give a reference of what we're looking at and trying to compare to. So here's an incident response model. And this comes from Mandia and Persisi. This is out of their incident response book. They were former Foundstone consulting members. So here's the phases they have. And you can see there's many more in their process than the DOJ one. So the first one we have is preparation. Again, we prepare for the incident, get ready for it. Then we have detection. Again, our focus here is more of incident response in a corporate environment, servers being broken into or other critical infrastructure being broken into. So you have some kind of detection phase, whether it's IDS or some user reporting an error, some reporting of an actual incident. We want to verify it in our initial response. There's a lot of false alerts on IDS systems, so we actually want to verify it's a real alert and not just some false alarm in the process. Once we get this, we have a strategy formulation where we say, okay, we think it's this system is fairly critical. We can't take it down. Let's use this approach, or it's not critical. We'll go through this method. Duplicate system. Again, it's the same process we saw before, using DD to copy it. This is a specific item in this model. Investigation, we search for evidence or other various techniques to find our evidence of the system the incident. Secure measure implementation, which is basically taking other measures to make sure that we can secure the system or other systems like it. Network monitoring, recovery, reporting. Again, all basic things of trying to make sure this doesn't happen again, so we can recover the system or we can monitor things to prevent further damage. So here's a basic example. This one we have Linux servers being suspected of being compromised by an outside person. We deploy our response team, and here are our basic phases here. Initial response is basically to we verify it by looking at logs for certain rootkit signatures. So when a lot of times people break into servers, they install rootkits. And there's many signatures of rootkits that we can easily detect. For example, there's some examples. So here's what rootkits are actually. Everyone? No? Okay, so rootkits are used basically to hide data. So we actually go through and they're deployed or installed on the system to actually hide data from the investigator. So it looks like a normal system when there's really bad things going on. So a common example is, to take the ls command in Unix, which basically lists the files in a given directory. So if the attacker installed files in the directory, they do ls. These are going to jump out as being files from the attacker. So what they do is they modify the ls so it hides those files. It's basically a configuration file somewhere that says, if you see one of these files, don't show it to the user. And this can occur at basic levels in the system, whether we modify the ls command, whether we modify the kernel, whether we modify libraries. There's several places we can do this, but the basic goal here is to have some kind of modify the system somehow so that the actual evidence isn't shown to the investigators. And we can do this for the ls command, the ps command to show processes, netstat to show open ports, etc. But there's some kind of signatures we can see in this process. So for example, in the dev directory on Unix, where we see all our device files, there's thousands of files in there in Linux, thousands of them. So, and they're all archaic names, like we saw before, HDD or PTYP0, all these very basic short names of various random letters. So a common hiding technique is to throw a file in there with some other archaic name, but put your configuration files in there, to put other things in there, which is a list of the files that should be hidden or processes that should be hidden. So we can find that actually by looking for signatures in that directory to see whether or not these have been installed in the system. We can do port scans to see if there's open Trojan programs that have been running to allow the attacker access to the computer. We can look at the logs to find out if they're missing log entries or if they're logs of the attack. Basic formal things we can go through to verify with basic techniques that we actually have an incident. Then we formulate our strategy. In this case, it's not a critical system. It's a basic secondary DNS server or backup web server. It's not critical, so we'll take it offline. Otherwise, we have to do some kind of online live analysis. So we use our DD to copy the system of the hard disks. And then we import our disk in our analysis tool like we did before. And we look for various things about our system now. Now our hypothesis is that we've been attacked by an outside person. And we're looking for various evidence of this attack. So Trojan executables, hidden data. We can use timeline analysis to find out what happened in the system. They broke in this time. We have activity over here at this time. Trying to map all these various pieces together. After we find out how they get in, we may want to patch the similar systems on the network so that others aren't broken into in the same way. We deploy network monitoring to record traffic. Then we rebuild a system from scratch so that we don't risk having any Trojan or bad executables on the system. So as the last one we'll get to, this is one actually again, the point is these are all very in different areas or approaches. The one that we proposed a couple years ago was on basically the crime scene. If you look at a physical crime scene, books for cops and law enforcement that go into an area, there's basically a set procedures that go when you get to this house to investigate the place. So we applied that to the digital world to see how well it mapped through. And there's 5 basic phases in this process. One is to preserve the crime scene. So you get there, you deploy the yellow tape around the house, you detain your suspects or your witnesses to find out, to make sure we have everyone who stays there, prevent people from walking through the house, and just kind of preserve the general scene. Then we do a survey where we take a brief walk through of the house or the building to find the obvious evidence to kind of get a scope or a feeling of what actually happened. We document with video and photographs and sketches and various things. And then we do a full search of the house or building for all the evidence. And then the final phase is reconstruction, where we find a bullet hole in the wall, or we find some blood splatter, and they actually do a reconstruction to find out, well, based on the angle of this, and we know what kind of gun it is, it probably came from this location or that location. Try to reconstruct what happened in the building. So the question is, can we apply this to the actual digital world? And this is what we actually do with this, and it's basically the same kind of thing. So we preserve it where we isolate the computer, we make a copy of it, we preserve the state of it. We survey it for obvious evidence, similar to the verification phase we saw with the incident response model. We document it, and we search and we reconstruct the events to determine how it got there. So we see these 3 models, and there's many others. But so what's the problem? I mean, these are great instruction training tools that we saw. They're insightful when you're learning how to do investigation about what the process is to use them. But the problem is that we're looking at trying to define technical requirements. That we wanted to define, how do we test tools? How do we create tools? How do we define